Hi, and good day to the panels, Dr. Shariza, Dr. Zurina, and Dr. Jeffrey. Today, I would like to present Bachelor Degree Project 1, which is my title as Synthesis and Characterization of MXene MOS2 Hybrid Electrode for Supercapacitor Application. My name is LEK WEE, and my supervisor is Professor Dr. Muhammad Ashadi. And now, let's proceed to PSM1 outlines. So for my PSM1 outlines, Chapter 1, which is Introduction, we start with background of study, then provide a problem statement, then later we set our objective and also study scopes, and later we provide the significance of the study, and also lastly ended with report organization. And for this page is the problem statement and objective. So our problem statement is the MOS2 is a promising material, but restacking of MOS2 resulted in low efficiency. So our strategy to take care of this problem is to design a novel heterostructure composed of MOS2 and MXene. So the 2D MXene, we know that it has good electrical conductivity and it can host many different cations between its layers. And the image below here is the SEM image of restacking MOS2. So from the description of the author, they state that the stacking of MOS2 will reduce the electrolyte penetration, leads to less active sites during charge-discharge process. Therefore, it becomes low efficient. So for our objective will be, firstly, to synthesize MXene and MOS2 hybrid by manual mixing using agate mortar. And second objective will be to characterize the structural and morphological properties of MXene MOS2 hybrid by using analytical techniques. And thirdly, our objective will be to evaluate the electrochemical performance of the hybrid material using cyclic voltammetry and also galvanostatic charge-discharge measurement. And later, this is the scope of study. We're focusing firstly on electrode material, MXene and MOS2. And later, we focus on material characterization method, which is SEM, XRD, and Raman spectroscopy. Lastly, we focus on electrochemical evaluation method, which is CV and GCD as mentioned before. Now this is a Chapter 2 literature review outlines. So firstly is the introduction, then later we proceed to general overview of the construction and mechanism of supercapacitors. So as below, show that the type of supercapacitors based on different charge storage mechanism, such as EDLC, pseudocapacitor, and also hybrid type. We also look into the application of supercapacitor in various sectors. And later we study on the two-dimensional electrode material, such as MOS2 and MXene properties, and different strategies to prepare each electrode supercapacitors. And later we study on the synthesis of MXene and MOS2 hybrid. Then we also briefly discuss on the influence of aqueous and non-aqueous electrolyte. And after that, we will provide the examples of material characterization such as XRD, SEM, and also Raman spectroscopy. And after that, we also provide the electrochemical evaluation examples, which is CV and GCD. And for this page is the material characterization example. On my left side here is the XRD pattern for MaxFast, MXene, MOS2, and also MOS2 MXene. And this XRD analysis performed by the author, which is to confirm the existence of MOS2 in the MXene layer, which form the hybrid. And on the right side here is the SEM image of MOS2 in higher magnification scale, which show the flower-like morphology, as we can see in the SEM image here. And for the Raman spectroscopy at below here, the author used it to further confirm on the material quality. And on the right side here, the Raman spectra performed by another author, they use it to prove that the confinement of MOS2 in MXene layers. And on the right side of this slide, which is the SEM image of MXene, as we can see here, the accordion-like structure, or we can say it formed layer by layer. And below here is the SEM image of MOS2 MXene hybrid, which show the disappearance of accordion-like structure, which cover up by the MOS2 morphology structure. So on this page is the electrochemical evaluation examples. On our left side here is the CV curves of penny MOS2 sample 1, 2, and 3. And for the best sample, they proceed to different scan rates to study its behavior. And below it will be the GCD curves of three kinds of material, which is MMX nanohybrid, MXene, and also MOS2. As we can see the GCD curves here, MMX show the better capacitive behavior. And on our right side here is the CV curve of MXene and MXene MOS2 films. And on its right is the CV curve of MXene MOS2 asymmetric supercapacitors. And below it will be the CV curves of MMX nanohybrid in different scan rates. Now we proceed to chapter 3, methodology. So methodology, we start with introduction as usual. Then we provide a flowchart of our experiment. Then with the listing of chemicals and laboratory apparatus as needed. Then we proceed to synthesis of the hybrid material, which we mix the material by using agate mortar manually. And then we provide a schematic diagram of both synthesis and electrode preparation process. And then we optimize the composition of MXene MOS2 hybrid in different wet ratio. And then after that, we will proceed to fabrication of the hybrid electrode by using conventional slurry coating. And later, we proceed to characterization and analysis of MXene MOS2 hybrid material in XRD, SEM, and also Raman spectroscopy analysis. And lastly is the evaluation method on electrochemical performance of the hybrid material, which is by CV and GCD measurement. So in this slide is the methodology plan for the hybrid electrode. So first step is the mixing of as prepared MXene and MOS2 material powders in the PTFE binder and super P conductive material in wet ratio of 80/10 and 10. And secondly, we add the mixture into the organic solvent NMP to form the slurry. So the prepared slurry will be later coating on the current collector. And lastly, followed by drying at 100 degrees Celsius for 12 hours in a vacuum oven to obtain our hybrid electrode. So for the last step, which is we repeat the procedures into a few samples with different wet ratio of MXene, which is the step of composition optimization. And now this slide is the characterization. This slide is the three major phases of methodology. So first one will be the fabrication and synthesis of hybrid electrode. And later we'll move to characterization of MXene MOS2 hybrid. And then lastly will be the electrochemical evaluation on the MXene MOS2 hybrid. And all these three phases will lead to result and discussion, which will be discussed further in PSM2. And lastly is our summary and expected outcome. So for our summary, we generally study related to our project titles. Then we provide a problem statement, followed by objective and also the study scope, and later provide a significance of the study. And in chapter 2, we gain our knowledge and also we strengthen our understanding based on previous studies. And later, in chapter 3, which is the methodology, is presented in three major phases, comply with our objective 1, 2, and 3. And lastly is the expected outcome. In XRD, we expect MOS2 peaks at 002 plane index, 100, 103, 105, and 110 plane index. And we expect that MXene peaks of index plane 002 will shift to lower value. And for MXene MOS2, we expect that the presence of low intense peaks index at 100, 103, and 110. And for SEM image, we expect MXene accordion-like structure will cover up with MOS2 spherical morphology. And in Raman spectra, we expect that the presence of Raman knots correspond to MXene and MOS2. And lastly, the CV curves, we expect large and ideal rectangular shape. And for GCD curve, we expect large symmetrical triangular shape. And that's all from me. Thank you very much.